State the general formula of an alkane containing N carbon atoms. Pretty nice question. CnH2n plus 2. Deduce an expression for relative molecular mass of an alkane in terms of N. This one's a bit of a tricky one, but what it's basically saying is treat N as the MR of these. So carbon and then just substitute in. So if we treat this carbon as, which is 12, M of carbon is 12, so it's going to be 12N. M of hydrogen is 1, 1 times 2N is going to be 2N. And this plus 2 is the same. So that will be 14N plus 2, therefore that is the expression. 14N plus 2. Explain why nonane has a high boiling point 2 for dimethylheptane. First thing you can see is nonane is a straight carbon chain. 2,2,4-dimethylheptane. It's got a couple of bent one. So it's definitely going to be because of that. Nonane is straight. Actually, nonane molecules, because they're straight and together, they're packed closer together compared to 2,4-dimethylheptane. As they're packed closer together, there's more surface contact. And as there's more surface contact, there's going to be stronger van der Waals forces between molecules. Nonane molecules are packed closer together, more surface contact, stronger van der Waals forces between molecules. 4.3. Given the equation for the complete combustion of nonane. Well, nonane is C9H20. So when it's complete combustion, you're adding oxygen and forming CO2 and water. C9H20 plus O2 to form CO2 plus H2O. So 9 carbons on the left hand side, 9 carbons on the right hand side, 20 hydrogens left hand side, 20 hydrogens left hand side. Just balancing out how many oxygens we have. 18 plus 10 oxygens, we have 28, so it has to be 14 here. The left hand side, 14 times 2 will be 28. So C9H20 plus 14O2, arrow 9CO2 plus 10H12. Explain how nitrogen monoxide is formed. Well, we've got nitrogen and oxygen from react at high temperature. It doesn't really, the mark scheme says ignore references to pressure. It just wants to prep a high temperature. So nitrogen and oxygen from air react at high temperature. Nonane can be cracked to form large quantities of propene. The type of cracking used. I was pretty confused for this, but then I saw that propene is an alkene, and one of the main uses of thermal cracking is to produce alkenes. And that's why it has to be thermal cracking, because it produces alkenes. Generally produce alkenes, and propene is alkene. Then it says the main use of propene from cracking is to make polypropene. Draw the repeating unit of polypropene. So we have to work on one for this one. But propene, polypropene, we're gonna have single bonds. Those straight ends as well. CH3 H, and that is polypropene, and the repeating is polypropene. That's the end of question 4.